All right, so good afternoon, at least for me it is. My name is Nico Koning, and along with Wolfgang Steffen here, we run a startup company called Ilumbra. We specialize in developing 3D volumetric models for use during interactive shows in planetariums. We also develop our own software called Illuvia, which can be used to view these models in science centers on a touchscreen exhibit or for online and offline teaching. Now, there are two main methods when it comes to representing 3D objects on the computer. There's surface mapping and there's volumetric modeling. Surface modeling involves creating a surface, which an image texture is then applied to. This works pretty well for solar system objects that are opaque and relatively round. But nebulae, on the other hand, they're neither round nor opaque, so there's no real surface to attach a texture to. So what you end up with is a bumpy 3D object that looks solid when close up. From a distance and straight on, sure, it looks pretty good, but basically what you're seeing is the texture image. As you come closer and look at it from different directions, you can clearly see the abrupt surface edges, and it kind of destroys the whole illusion. Also, flying through this kind of model is pretty much impossible because once you pass through the surface, there's no more texture and it just goes dark. So as a presenter, you're kind of restricted in what you can show the audience, and you have to be careful where you go. Otherwise, that whole feeling of flying through space will be gone. Now, volumetric modeling uses a different approach where the emission actually comes from all points in space instead of just on the surface of an object. So each voxel contains a brightness, and these are added together along the line of sight to give a final image. This gives a much better viewing experience as there's no real sharp transitions due to the surface. And you can fly all the way through and around these kind of objects. Now, here is an example of a surface mapped object, Orion. It's a surface, slightly deformed, and then a texture is applied to it. And it looks pretty good straight on, but as soon as you start to rotate around it, you can start to see that the sharp edges of the surface. And it doesn't really look like you're in a nebula anymore. Now here is a volumetric model we made at Ilumbra. You can see as you rotate around it, it still maintains that gaseous look. There's no sharp edges, and you can even fly all the way through. Go inside, take a look around, and there's no real, there's no surface to confuse you with. So it looks pretty good. So this is what we mean when we talk about volumetric models. At Ilumbra, we've created over 30 of these models, and we're continuing to work on new ones. They span a wide range of objects like stars, quasars, star formation regions, planetary nebulae, supernova remnants, galaxies. We create both generic objects, which are relatively easy, and specific real objects, which are much harder to do. We can also take custom orders. So if you don't see an object on our website and you want it, just send us an email and we'll make it for you. In addition to creating 3D volumes, we've developed our own viewing software called Illuvia. Our main aim with Illuvia is for interactive touchscreen exhibits in science centers. So the kids would play on here, they'd move around the objects with their hands. And they'll learn something about the structure, formation of these objects while having fun doing it. We've also included a game to help people understand the role orientation and viewing angle has in astronomy. And there's an animation studio where you can create fairly complex animations that you can use in presentations on websites or pretty much however you want. There's several modules in Illuvia. The first is the Explorer module, where you can just play around, look around the object, fly through it. Here's an example of the Explorer. I'll also use it as a chance to show more volumetrics. This is Centaurus A. It's a galaxy with a supermassive black hole in the center that's creating a jet that you can see there. So you can just rotate around, fly in and out of it. Here's HH47. This is a protostar that's ejecting a jet as well, and that's crashing into the surrounding nebula, lighting it up. Here's the sun. This is not a surface map model. This is a volumetric model of the sun, which allows us to do things like looking into it. So we can slice the volumes, so we can peer inside the more opaque objects. And as a presenter, you can use this to show what's inside of the star if you want. And here is the Eskimo Nebula. It's a planetary nebula. There's a white dwarf in the center, and we can just fly in and look at that if we want, and then look around from inside the nebula. So that's the Explorer module. Now we also have a match game where the point of the game, well, the orientation of the object's kind of rotated and scrambled, and you have to rotate it back to look like it does from Earth. So it's kind of a fun way to teach about how nebulae and galaxies look from different angles. So I'll show you what it's like. You choose the object you want to play the game with. And on the right is the Earth view. And you click Start, and it will scramble the view on the left. And now you have to rotate it around to try to match it up again. Once you think you have it right, you click Check. And nope, you got it wrong. So now you try again. And you click Check again. And you have it right. And then it will show you a bunch of rankings. So you can compete against other people who have tried this all over the world, hopefully. We also have, the animation studio, which allows you to create fairly complex camera animations using keyframes. These animations can then be downloaded as a video and used in presentations or any way you want, press releases, movies, etc. At Ilumbra, we also try to promote 3D astronomy and discuss the advantages, disadvantages, and challenges of creating these volumetric models. We have taken out several articles in the planetarium where we address these issues. And we also have a research blog in which we discuss the most up-to-date research and advances in 3D astronomy. And if you like, you can join that blog by visiting 3dastrophysics.wordpress.com. You can get more information about everything we do, including what models we have available. Just go to our website, elumbra.com. And our models have already been incorporated into a bunch of different planetarium systems. So it's likely you've already experienced them in the Big Dome. If you'd like to see more models or you want some custom made that aren't on our website, just send us an email and we'll make them for you. Okay, now there's a short presentation by Digital showing some of our galaxies that we've created. So I'll turn it over to Dave and Wolfgang. And I have to unshare my screen. There you go.
Hello, everybody. Yes, this is Wolfgang, Steffen from Ilumbra, and I see Dave coming up. Dave will be our pilot through Nightshade and the volumetric models that they have on their system. Here we have the Milky Way rotating around. And if we can go edge on, so to see a few of the features that we incorporated from the recent science on the Milky Way, for example, its warp. Maybe we can rotate around it a little bit more around the axis to see the warp. Yeah, almost, kind of. Maybe a different angle. Yeah, there you go. There we can appreciate the warp of the Milky Way. And if you look at it from the top or bottom, we can see that our galaxy is actually a barred galaxy with a small bar, and it has a bit of a peanut shape in the middle. And that's, say, the main characteristics that we can show with this model, and many other details that you might want to show in the volumetric model of our Milky Way. The dust lanes are there, of course, that are very well visible from the side, especially in spiral galaxies. And we can compare this in the local group with the Andromeda model. If we go to Andromeda now, just for a day excursion or something, a few 100,000 million light years away, we can see that the Milky Way, Andromeda is quite similar to our Milky Way actually in a way, but with a few differences, such as the middle, it does not have a bar. It's a more roundish core of the old orange or yellowish stars. If we look at it from the side, from the edge, then we will be able to see that it does also have a warp, which is most likely due to the interaction with the smaller galaxies, the satellite galaxies that we can see as well. The elliptical galaxy that might distort the plane of the bigger galaxy. Similarly, our own galaxy, our Milky Way, has satellite galaxies that do interact with the plane of the galaxy and do this kind of distortion. And that's the Large Magellanic Cloud. Are we going there?
We are.
The Large Magellanic Cloud is very interesting, amazing galaxy with a lot going on, star formation and a lot of dust. And there, if we look at its edge on, there's an interesting feature. It does have a distortion as well, but it's not a warp, apparently. A warp is different. This one has a parabola shape, apparently, because of the motion around our galaxy. The core, the center, is not in the plane of the galaxy, and everything is a little bit distorted, but it is a barred galaxy, as is easily visible from Earth, actually, in the southern hemisphere. And it has a lot of star-forming region, which we can see as pink areas or regions. Now, if we go to the Small Magellanic Cloud, we can see a very interesting feature that we've incorporated from the scientific literature that investigated the distribution of stars in the Small Magellanic Cloud, which we don't appreciate from Earth, actually. From Earth, it looks like a small kind of elliptical patch. It is slightly deformed, but from a different view, this is about the Earth view, kind of this shape that we see from Earth in the sky. But seen from a different direction, it is revealed that it's like a worm in space, a space worm, really very elongated along the line of sight, with some curvature and very complicated structure. This is all due to the motion around the Milky Way and the gravitational interaction with the Milky Way that can be appreciated. Also, there's a lot of star formation going on in the molecular clouds and dust regions that we can see as opaque areas in the volumetric model. Okay, this is roughly what we have. We have one more additional galaxy in this local group set of volumetric models. This is M33. Is that right?
Yeah. Yeah, M30, the triangulum galaxy.
The triangular galaxy, right? This is a bit far off, and this is a smaller galaxy. It doesn't have these massive companions that distort the structure of the spiral, and there's no warp incorporated in this model. So thank you, Dave, for this voyage around the local galaxies. and that are our neighbors. And so we continue with this concludes the sponsor presentation from Ilumbra.